The geologic timescale is a chronological system used by geologists to keep track of different points of Earth's history. It allows us to easily, uniformly, and quickly refer to different points in Earth's history. Based off of isotopic radiometric dating of crystals, such as zircon crystals you can find in rocks in Jack Hills, Australia, and as well as isotopic dating of materials found in meteorites, the age of the Earth is estimated to be about 4.5 billion years old. So when you're referring to any point in Earth's history, you have a lot of different eras and eons to choose from. So when we're talking about Earth's history, you might wonder why geologists don't just say this many years ago and call it a day. Why not just more easily say how many numbers of years ago it was, or millions of years ago, without adding on these words that sound really foreign to you? Well, the example I use for that is, let's say I'm telling you a story of what I did last year. And I start off by saying 350 days ago I did this. You're probably just stuck wondering how long ago was 350 days ago. Maybe you're wondering, why did I keep track of that? Or you're just totally confused of why I wouldn't just say the month or the time of year. It's the same thing goes with geologic time. So if I'm referring to the time when woolly mammoths walked around and there were saber-toothed cats roaring throughout Los Angeles, I could say 10 to 11,000 years ago was the last time that might have happened. And so that gives you the numerical age, which exists in geologic time. Or I could refer to it as the last ice age, which is also when it was. Or if I wanted to be more specific in geologic time, I could say it happened during the Pleistocene. So similarly, when I'm talking about last year and I say it happened 350 days ago, you know that with how big a year is, it probably happened around this time last year, but it'd be much easier if I were to say something like, when I said last ice age, I could say last summer, and that gives you a span of time that it could have happened in. Or I can be more precise and say last July this happened. And then again, it helps you to narrow down when this time frame was. I can be really hyper specific and say, July 4th at 12 noon. And we could do that in geology too. But more likely, we're going to be saying the words or names that associate with different time periods. So some of those words or names have meanings that hold relevance today. But just like the days we have, or the names we have for our months, some of them used to have finite meanings, which then lost relevance. Or perhaps there's that meaning, but it doesn't really matter too much to geologists. So examples in our calendar year, you might have noticed that September, October, November, and December have prefixes that relate to numerical values. Sept, Oct, Nov, and Dec, respectively, mean 7, 8, 9, and 10. However, December is not the 10th month of our calendar, it's the 12th month of our calendar. But back before the Julian calendar, the one that Julius Caesar named July after, back before that one was phased out and we're using our current adaptation of the calendar, there were 10 months and December was the 10th month. And when you're looking at calendar or month names like July and August, July, named after Julius Caesar, and August, named after his son Augustus, yeah, those are still the names. Even though December is no longer the 10th month, July still relates to the name given by Julius Caesar, and that's an easy way to remember that those are the months that have 31 days because the guy who was in charge named it after himself, so of course he gave himself more days. But when you're looking at those, it doesn't really mean any different when we're in July. It doesn't all relate to Julius Caesar. So when you're looking at geologic names and you see a specific name, don't read too much into it. Sometimes they do have relevance and do make a lot of sense given the substrate, but other times there's a meaning that has been given, has lost meaning, but it's stuck. So moving on to geologic names and time periods, and I'll go into some of those meanings that still make sense now. For those 14.5 billion years that the universe was around, the Earth was only around for 4.5 billion years. So I have up here the age of the universe, 14.5, but only about 4.5 for our Earth. And we break that up based off of, first, what the rocks look like. So with this time scale, I have images that represent the fossil assemblages you would have found in those ages of sediments. The large geologic timescale I have up here does the same. We have all the fossil assemblages listed here, and the names listed here, and the numerical values along the axis. I know it's all too small for you to see on the camera, but this is a really good way of seeing the fossil assemblages alongside the names we give them. Before fossilized organisms were discovered in the rocks, there's still pre-existing sediments or pre-existing substrates. So we have fossilized macroscopic organisms dating back to the Cambrian, and then the Precambrian. There may still have been single cellular life, but it didn't make it into the rock record in such a recognizable way as you see with these fossils here. So for the Precambrian, rocks that don't have the macroscopic fossils, you see it sort of squashed down to the bottom. There's several billion years there of Earth history that don't have large fossils found in them. And then in geology and paleontology, as well as in my dinosaurs course that I teach, we tend to stick to these larger chunks of time, or these eras. So the Precambrian, down at the bottom, goes into about 600 million years ago. Then you move into what's referred to as the Paleozoic, Mesozoic, and the Cenozoic. Those three large chunks of time are the eras. So when you're looking at the breakdowns, the broadest chunks of time would be era, more narrow would be period. Then we have this word here, and I know it's spelled a little different than the word epic, like saying, oh, that's epic, or mega, but it's pronounced in basically the same way. So you can say epic for this one. And then we have age being the narrowest span of time. So these eras I have listed here, the Paleozoic, Mesozoic, and Cenozoic, all rely on the Greek root word referring to animal. And since I said it relates to the fossil assemblage, that makes sense that it would be based off of the animals or life that was found within those rocks. So you know the word zoo from zoological garden, where you would find animals housed, so a garden of animals, or a zoo as we call it now, it's an abbreviation for zoological garden, has the root word zo, like in the study of zoology, and it comes from, I don't know quite how to say it, but I think probably zoion or zoon for the Greek for animal. So for our most ancient animals, fossil assemblage, we're going to refer to it as the Paleozoic, or the ancient life. So Paleozoic are the oldest fossils. So there we go, Paleozoic. And then for the middle life, just like the middle level in the theater is referred to as the mezzanine, or the middle tier, the middle chunk of life, or middle animals, would be referred to as the Mesozoic. Mesozoic is the time during which dinosaurs first appeared, and then at the end of the Mesozoic, dinosaurs disappear from the fossil record. If you take my dinosaur class, you already know all about the Mesozoic, or middle life periods, or spans of time. So Paleozoic and Mesozoic are our first two large eras. Those are then broken down into periods, which I'll show you in a second what the different names for those are. And then now moving on to our current or modern span of time, we have the Cenozoic. So Cenozoic is our current era that we are in. So that Ceno part, we know the zoic refers to animals, zoos are animals. So blank zoic has to do with something life. So we know in Cenozoic that's life. But what is Ceno? Cen, like the word recent, comes from the Greek kainos for new. So if you say something's recent, it's a new happening or a new event. And so we have the Cenozoic, that's our new life, the most recent life on the planet. And if you move down into periods, which we'll cover the periods in a second, epoch and age, you would find that humans are currently in the epoch referred to as the Holocene. So I told you scene means the recent or current or new, and then that prefix holo refers to whole or all of it. So all of the new or modern life that we see today, right now, belongs to the all new or whole new, like whole new world, belongs to the whole new epoch that we are in. So humans right now, we live in the Holocene epoch, and that'll show up on the Geologic Maps lab as well. So remember this word Holocene. This is the epoch that we live in right now. So the Holocene epoch, that is us currently. So if you're referring to the Cenozoic, how far back did the Cenozoic begin? It started about 65.5 to 70 million years ago when the dinosaurs disappeared from the fossil record. So now we're going to get into the scientific notation for chunks of time. So I just referred to millions of years ago. And this one's going to be the easiest chunk of time because when you say millions and you see MA, you're going to automatically know, well, chunks of time, millions, that's the only M chunk of time I can think of. So MA is millions. MA here with the Latin-based notation actually stands for mega annum, or you can do the English abbreviation or English acronym here of MYA, so million years ago. Or you can just do the numerical value, and you can see that million there has the 6 zeros. So for spans of time, all of these ones are in millions of years ago. So that's all millions. If you're looking further back than that, now we're going to get a little bit confused because you see here I have a G on the board. There we go, GA for billion years ago. But billion starts with B. What am I doing putting a G on it? Well, again, we're going back to the Latin root of it, or the Latin nomenclature for this. So GA is gigaannum, and we do it capitalized there, just like with the MA for mega annum, I put it capitalized. And then we have the lowercase acronym, going back to our English nomenclature. BYA is billion years ago, and you can see there that billion has the 9 zeros, so you can also do numerical on that. But because all of our stuff that's billions of years ago predates the macroscopic fossils that we would look at when we're doing something like relative dating or index fossils, that's not one that's going to come up very many times in our geology labs. So there's billion. And then now moving on to recent times, like I said, the Ice Age ended on the scale of thousands of years ago. So now we're going into thousands. Now many of you watching this, if you are enrolled in my geology lab, I know that the age groups of those who are enrolled are by and large individuals who are early 20s and younger. So there's a good chance you don't remember the whole Y2K year 2000 business. But when the year 2000 was approaching, at least here in the United States, there was all this memorabilia stuff that you could buy where you could be like, yeah, I was around in the year 2000, big whoop. But you can buy some stuff that would say Y2K on it. And that K had to do with the 1000, and it also has to do with the nomenclature you might see when you're using the metric system. You're talking about kilograms or kilometers. That kilo prefix refers to 1000. So you see that again here. When we go into the Latin nomenclature of Ka, it's kilo annum for thousands of years. And then in the English one, because we do use the prefix kilo so much in English for kilograms, kilometers, Y2K, these two are used pretty interchangeably. We can do KYA for thousands of years ago or TYA for thousands of years ago. And then, of course, we just have the 3 zeros for thousands. So here's our thousands span of time. So we know that we live right now in the Cenozoic. The period that we are in is referred to as the Quaternary, and I'll get to that briefly because in a little bit, I'll be going over the periods that belong to each of the Paleozoic, Mesozoic, and Cenozoic. So we are currently in the Quaternary period, and that one's going through some changes. Geologists are constantly tweaking or adjusting the names of geologic timeframes to be more applicable, more sensible, in terms of making sense to geologists in any nation or any point in history. And then also some of the names are changing because of the locations of the newest isotopic data. So we are right now in the epoch called the Holocene, and this is a fairly recent term that's come out. The Megalayan is the age that we are in, and this name here comes from the cave in India where the isotopes are found to put the parameters on this age here. So we are here in the Cenozoic in the Holocene. But let's say you wanted to look at different periods in other portions of time. We're first going to talk about the Paleozoic periods, and I'll give you a mnemonic to help you remember that. The Mesozoic periods, there's only 3 of them. They're pretty easy to keep track of. And then the Cenozoic periods, they're not going to be referred to a lot in this geologic frame of reference because we are going to be talking about either strictly Holocene specimen or we're going to be looking further back in geologic time when we're referring to things in this class. But if you're looking at things from the Paleozoic, you are going to have all these little smaller periods, or far more numerous periods than you would find in the Cenozoic or the Mesozoic. So we have a mnemonic for all of these periods in the Paleozoic. So the periods listed from oldest to newest are the Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and Permian. Mississippian and Pennsylvanian were first given names based off of where in the United States those relevant sediments were found. They have been renamed the Carboniferous, and I underlined and broke up the word here so you can see that based on carbon. These are the carbon-rich sediments, the carbon-rich strata that you would find in Mississippi, Pennsylvania, and then of course, because that geologic era, that geologic happened all over the world. It's not like just one city gets a Tuesday or something. It's like this entire planet went through this time period. So it was renamed the Carboniferous rather than being so specific to these two sites here. But you still find the names Mississippian and Pennsylvanian on, I'm seeing here that I'm probably missing some letters on Mississippian. Yeah, I skipped some S's because it's a long word. So the Mississippian and Pennsylvanian have been bundled into Carboniferous. So if you were trying to remember the order of these ones, you would think of the handy mnemonic that makes no sense when it's all blank here, of COSDMPP. And the way you would remember that is this horrible horrible mnemonic that was taught to me by my graduate advisor, and it has stuck in my brain, so maybe it will for you too. So it is come over soon, dear, make party party. And he did the dance too, so I will. So make party party. Come and party with your dears and have them come over soon. So there we go. Come over soon, dear, make party party. And those letters respectively stand for the Cambrian, Ordovician, Silurian, Devonian, Mississippian, there we have it misspelled, Pennsylvanian, and Permian. So those are the periods of the Paleozoic. Now moving on to the Mesozoic. Most of you, probably all of you, have heard of Jurassic Park. In the movie Jurassic Park, at least in the first one, and also dinosaurs that are heavily featured in a couple of the other ones, not all of the organisms seen came about or thrived or were even present during the Jurassic. However, when Michael Crichton was writing his book and looking at test markers and test groups and referring to the different time periods, this word here didn't fare very well. The Cretaceous is the time when most of the dinosaurs in Jurassic Park actually lived or were most abundant. So it really should have been called Cretaceous Park, but people don't know how to say Cretaceous. You may mix it up with Crustaceous, and that would be crabs, and who would want to go to a park full of crabs? So instead they called it Jurassic Park instead of Cretaceous Park. But you know the Jurassic already. The Jurassic has some stuff in common with the Triassic too. So the way these periods were named, like I was saying, are month names. A lot of them have no real meaning anymore. These ones have a fair bit of meaning yet. So the Triassic is the oldest of the three periods in the Mesozoic. The Triassic is so named because it has three distinctive levels, or three distinctive sedimentary layers within it. There's the lower, middle, and upper. So because it had those three layers, it was referred to as the Triassic. Then you go on to the Jurassic, also had three layers, but the name Triassic is taken. And also refers to Jura here. The Jura Mountains are mountains that run between France and Switzerland. There is a Swiss coffee machine company called Jura. So this Jura word here, you might have heard it before, and it refers to a place where the related outcroppings or sediments were originally studied in depth. So the Jurassic sediments from the Jura region, the Jura Mountains, is how this one got its name. But of course, those sediments can be found globally as well, anywhere that they're exposed at the surface. Then we have the Cretaceous. And you know the word crayon? It has the same root word etymology as Cretaceous. So crayon comes from the Greek word for chalk. There's the name brand Crayola, which mixes crayon and oil because there are these little oil crayons that were made, and I guess they're more of a wax, but that's how they got their name. So this cray here, that has to do with chalk. And the Cretaceous sediments are very chalky sediments. It was the time when there were shallow seas pretty ubiquitously throughout the globe, allowing for thick layers of marine deposits of white limestones and diatoms. And so you have all these white chalky deposits that gave the Cretaceous its name. So Triassic, Jurassic, and Cretaceous are the three periods in order of oldest to newest for the Mesozoic. And now getting up to the pretty arbitrary names we have for the Cenozoic. We have these two words, tertiary and quaternary. Just like the Mississippian and Pennsylvanian got bundled into Carboniferous, these two words are going through some changes. Tertiary refers to third. We don't have a secondary or a primary period, so it's a little silly that it's called tertiary, but it's kind of like a placeholder. Like when you look on the periodic table of elements, and there are those later elements that are just given the names of like trium, and they get a proper name later. That's sort of what these ones are like. We have tertiary and quaternary, but slowly in geologic texts, you see tertiary is being replaced with paleogene, gene like genesis or origin of animals. So this would be in the ancient or old genesis of modern animals. And then the quaternary, which officially means fourth, but is being referred to in some geologic texts as the neogene or the new genesis of modern animals. But if you're looking at many different points of reference to look and see what period do we live in, what epoch do we live in, you'll see that we're in the Cenozoic era. The period is still widely listed as quaternary in many resources. And then for our epoch, it is definitely the Holocene. The age has a fairly recent name of Megalaean. Here on this time scale, it's the Versilian. So that part might change, but if you